Well, hello everyone, and welcome to Working with Smart Cards, macOS and Security. Before we really get going on this, unfortunately, I have to do some rather boring legal stuff. So, the big ticket items are, I am not representing any employer, past, present, future. All the information in this is specific to the OS. It is not specific to any place that I may have worked. We're dealing with a particularly complex topic, so this is the basics. It won't transfer to your environment as is. You are going to need to do a bit of work, but it's a good to get you started. And because of that, if you could please leave questions to the end if we've got time, and if we do run out of time, grab me at any point during the conference, and I will try and give you as best answers as I can. The next big thing was I was told there was a few things I shouldn't say here, which are APT, big data, cloud, or cyber, so of course I never said those. As a small surprise, those of you who've been paying attention may have noticed this box here. This is what I like to call bribery and corruption. So I live in Switzerland. I have brought a big box of Swiss chocolate. Please come down, please help yourself. I'm taking a leaf from Rich Troughton's book. So please come down, help yourself, make sure you leave me one. So a little bit about me. I've had very few permanent jobs. Most of the jobs I've had has been as an independent contractor. I've worked in publishing, I've worked in finance, I've worked in education. I've now been in 3 separate countries since 2005. So I started in the UK, I spent some time in Saudi Arabia, and these days I now live in Switzerland. And I'm hoping for the US at some point next year, because the application process takes a little while. And as you can see there, the application has been in progress since May last year. If you want to find me on Slack or Jamf Nation, my username is Franton. If you want to find me on Twitter, I'm under my actual real name there, Richard Purves. And I have my own website there. And with all ado, so to keep Ben Tom's Mac Mule happy, what am I faffing on about today? So we're going to cover a little bit about what Apple's doing with these things internally. We're going to cover some of what kind of cards actually exist out there. We're going to go through some of the basics on how to make these things work with, if you've noticed, I use the old term OS X as well as macOS. We've got some final thoughts, and all of these slides and all of this information you can find as a link off my GitHub. I have posted the blog. That should be going live on this MacAdmins blog page at some point in the next few minutes. So, let's start with a little bit of a security primer. So, back in the dark distant days of OS 10.4, there was a movement inside Apple because they had some American DoD customers to implement smart cards and the capacity to deal with smart cards. And to that end, they implemented 2 standards, which is the Common Data Security Architecture platform that was originally developed by Intel. And then there's the interface, which is the Personal Computer Smart Card interface. PCSE is still used. And then you got to 10.7, and all of this work mysteriously got deprecated. And as I've since found out, it was deprecated to allow more third parties time to support, because it was a rather confusing marketing period for Apple, where Apple said, yeah, this just works. And you had third parties trying to sell products, and they couldn't because it just worked, even though it didn't. So what they did was they open sourced it. And if anybody remembers macOS Forge, that's where all the smart card services actually ended up. And it was there until September 2016. And then I looked at it one day and then found that the entire thing had been moved to GitHub, because I think it was like the last active project on macOS Forge. And that allowed them to then get rid of macOS Forge. So, did anyone watch any Black Hat videos from 2016? There was an interesting one from a guy called Ivan. He was talking about security and iCloud. And the biggest takeaway that I got from that video was the fact that Apple was starting to use smart cards internally, because they are using them as part of the the Cloud Key Vault for iCloud. They have some admin cards, and that's what they use to make sure that no one person has direct access to what's effectively your iCloud data. And to this effort, they created a new API, and they called it Crypto Token Kit. And that started appearing in 10.11, but it really came to the prominence in Sierra from 10.12 onwards. And this is now starting to replace the old deprecated standards. So, let's hear from Ivan what they actually do with these.
Then, the cards are combined using a novel physical one-way hash function. This is our crypto blender.
I smoke. Don't breathe this.
Yeah. Okay. But what that basically means is they set up 3 admin cards, and they then shred them so that nobody has admin access to that system once it's been set up. And if you continue on that video, what actually happens is if they need to fix any bugs in the system, they spin up a complete new system, and when your phone activates, you swapped over to the new system. And then when everybody's off it, they just close it off. So Apple has gone out of their way using smart cards to make sure they have no access to your data, which is pretty cool. So what are the things? Well, actually, there's 2 different kinds. So you've got single-purpose cards and you've got multi-purpose cards. We'll cover some single-purpose cards first. These are public transit system cards. You've got the Ventra card from Chicago, Charlie card from Massachusetts, Smart Trip card from the Washington, D.C. area, and GoTo card from Minneapolis. And I do actually have all of these, because I spent a lot of time on US public transport. Certain other cards would be things like hotel key cards and loyalty cards. And when you actually have a look at these things, everybody's aware of the mag strip. But that yellow picture there is actually the magnetic information that's coded on these mag strips. There's 2 tracks in that picture, there's sometimes 3. And what they are is the same small set of repeating data over and over. And they do that to ensure reliability, so that if somebody accidentally wipes a magnet near one section, you'll probably still get a readable section somewhere else. So it's just the same set of data repeating over and over. When you have a look at contactless cards, as is more prevalent in Europe, what you actually find when you crack the things open is you've got a little chip there in the corner, and it's attached to a big loop of wire that's acting as an inductance loop and an aerial, which is pretty neat. You just hold the thing near the reader. It gets enough power through inductance to power up the chip, and that acts as an aerial to get the information off. But it's still just basic identifying information and nothing more. So like I say, there's no intelligence to these cards. And all the processing logic is on a back-end system somewhere. So yeah, these things are basically Citrix. Yeah, that joke didn't work. Never mind. Yeah, exactly. So multi-purpose cards, and this is the one that's going to be more interest to you guys. These things are actually computers you don't control. And when you actually have a closer look at these things, you've got things like credit and debit cards. So I know in the US, chip cards are starting to come in more and more. They've been quite prevalent in Europe and other places for a little while. You can see on the back there, you've actually got the back of the chip pad. That tiny bit in the middle of the chip pad is the actual chip itself, and the rest of it is just a contact pad. And then you've got the 2 wires coming off to act as the contactless and inductance loop, and they run round the outside. You've still also got the mag strip on there for backwards compatibility. You've also got things like SIM cards. Those of you who are on a non-CDMA network in the US will have seen these. These will be in every single phone. And these things are kind of similar technology. And then you've also got things like computer cards, you know, to do login. A great example is the DoD CAC card. And when you actually start having a look at what's actually behind the technology behind these things, you find that they're actually quite simple. So I just did a quick search and found that Atmel makes a nice, complicatedly named platform. It's just a simple 8-bit CPU. It's got a few kilobytes of ROM. It's got a little bit of EEPROM for permanent storage. It's got a little bit of RAM for working storage. The clock speed's not terribly high. It doesn't have to be. There's usually some dedicated crypto hardware in there as well, you know, for doing cryptographic work. And like most electrically erasable read-only devices, you know, you've got a limited amount of erase-write cycles. Most of the time, you're just going to be reading from these things. And that's actually the spec of a mobile phone SIM card from Europe. You can get them with more memory, you can get them with less memory. It depends how much you're prepared to pay and what your capabilities and requirements are. These things actually run operating systems. The big one that's usually the one of choice is Java Card. And yes, that's right, it's all Oracle's fault. The advantage to it is portable, mostly. It's mainly used in mobile phone SIM cards, but it's starting to get traction everywhere else. And for those of you who are Java programmers, you have no characters, no strings, no floats, no multi-dimensional arrays. Integers are optional. There's no standard API, and there's no threads. So every time you go into your iPhone or other phone, and you bring up an application out of the SIM list, and it displays a message, someone has coded that byte by byte. Which is why these things tend to be quite simple. Nobody really wants to spend the time. The other big OS out there is called Multos. It's the multi-application smart card operating system. There's a big consortium called Multos who oversee this. And it's mainly used by financial service companies. There's a good chance that your chip card from your bank is running Multos. And I couldn't really find out any more information because the Multos website requires you to install Flash. Yuck. The latest one is .NET. So these are cards made by a French company called Gemalto. They do run .NET framework on a card. So you can write .NET applications in Windows, upload them to the card, and probably have them work. But it seems to be deprecated. Because the latest line of Gemalto products seems to be going back to in favor of Java Card. So, who wants to know how many examples of smart card there are out in the world? Okay. Anyone here from Pennsylvania? Anyone here familiar with the Pennsylvanian YouTube channel Regular Car Reviews? Okay, you do. Well, so for the record, Mr. Regular of Regular Car Reviews allowed me to use a section of one of his videos in the next part where I show how many smart cards there are worldwide. Take it away. Yeah, there's quite a few of those. Right, so let's make these things actually work for you. The first thing you're going to need is some sort of USB card reader. And if you give me 1 second, because I didn't do this earlier, I actually have one of these with me. This is an OmniKey 3121. This, as far as I'm concerned, is the best card reader I've ever come across. It's got a detachable bottom, it's got sticky on the back, and this thing works with just about anything. The next kind of card reader that I've come across, and Apple actually sell these on their website, is the Identiv SCR 3500. These are nifty little devices because they fold away, they're nice and compact, they're transportable, they're a little delicate. But Identiv also makes some other card readers. So this is the 3500A, and they also have another one called the Identiv Cloud 2900R. And yes, that is the same picture, and deliberately so. You need a magnifying glass to tell them apart. There's plenty of others on the market. You may or may not have mixed results with them, but these are the best ones that I've found so far. You're also going to need something to actually read from the card. You're going to need a set of drivers, and these are called middleware. They are usually supplied by your third-party vendors who've supplied you the card in the first place. Certain government standards like CAC and PIV are natively supported by macOS and other operating systems, especially PIV right now. both Centrify and Thursby have products that support these by default. And anyone who's done any work with the DoD will have probably bought one of these two products at some point. So, let's get on to the actual OS configuration. So, the first important thing is the login window. If you're used to having username and password boxes on your login window in your corporate environment, that's not going to work. You got to go back to the little tiles. Because I don't know why, this seems to be something, this is a bug I filed with Apple, had it closed as a duplicate. If you use the login window, it doesn't work. If you have the little tiles, it works every time. So I've provided the payload type, the key, and what you have to set it to. My advice, which will become clear for the rest of the talk, is use config profiles. You can try using defaults right, but I don't guarantee them. So that's the information you need for a config profile to make it work. The other thing you're going to need is some drivers to actually interface to these devices themselves. It's kind of an optional. Apple has taken some third-party software, some open source software, and to be honest, it works 9 times out of 10. Shouldn't really need to worry about this too much. But just on the off case that you have a use case that does require the manufacturer driver, the OmniKey 3121 driver is pretty good. Like I say, it shouldn't be needed. However, the little fold-out card readers has probably the world's worst macOS driver package that I've ever come across. Is Gregg Nagle in the room? Good. We won't have to deal with the explosion. He likes properly made packages, and so do I. And if you actually want to have a look at these, I did some screen grabs. And take a look at that bit at the top there. Post-install and post-upgrade script need to be identical. If you modify this, please synchronize with the other one. I guess nobody's ever heard of symlinks. And then the next page is, I mean, that's horrible. It's writingplists with echo commands. I mean, that's just horrible. Yeah, okay. So if you're dealing with older macOS from 10.6.3 to 10.11.5, you're going to be dealing with the older methods of doing things. And the first thing that you're going to do is you need to twiddle with the authorization database. They actually provide a specialized command to allow these things to work at the login window. And it really is a simple matter of running that command as root, and it does all the changes for you in the background. So you don't have to get your hands really, really dirty with this. Next thing you've got to do is you're going to need whatever certificate is on your smart card, you're going to need the root CA for it installed on your system. Or, in the case of certain organizations, you might need multiple root CAs installed on your system. But you're going to need that so that the certificate on the card can be trusted. And the best way to deploy that is, of course, via a configuration profile. Because as far as I'm aware, that's the only method that allows an installed cert to be automatically trusted by the OS. If you try it any other way, users got to go in and trust it. If you've installed it at system level, user doesn't have admin rights, they can't trust it. You've got problems. So like I say, it will not work without that certificate trust relationship. The next thing you're going to want, from a security point of view, is this little bad boy. So for the screensaver, what you can actually do is you can configure it so that whenever you take the smart card out of the reader that you've logged in with, it will, for security reasons, automatically kick you out. This option does appear in System Preferences under the Security menu in Advanced tab, only if you've got a smart card paired to an account, but we'll get to that in a second. But you can set it here via config profile. Do not try and do this with defaults rights commands or any other kind of plist twiddling. As I'm sure you tried earlier, it has a nasty habit of unsetting itself, sometimes almost immediately. So forcing that preference on with a config profile is pretty much your only option at this point. Again, I've also filed a bug with Apple about this, and again, they've also marked it as a duplicate. So that's some of the basic security. How do you attach a card to a user account? Well, you've actually got 3 different methods. And the first one's called hash matching. So you actually get the hash value of the certificates on the card, and you use a command to attach it to the DSCL record on the machine. The next one's a little more complicated. It's called attribute matching. You can put a file on the machine, and it allows parts of the smart card certificate to be matched to directory services attributes, either through Open Directory or more commonly Active Directory, like a user principal name. And pkinit deserves its own section, because pkinit's complicated. So we'll start with some hash matching. The basic command to make all of this work is the scauth command. And if you want to actually see the hashes of any cards plugged into the system, you run scauth hash as root. If you want to add that hash to a specific user account, you can do that with the accept command. And if you want to see what hashes are paired to a particular account, you use the list command. Seems quite simple. So this is what it actually looks like when you try and do it. So I ran the scauth command up there at the top on my test machine. This is on a 1011 machine, by the way. And that will become clear as to why later. You've got the list of commands, you've got the list of options that it needs. I run sudo scauth hash. I get the hash details of the smart card that I had plugged into the system. I also get hash details of other certificates it's found, which in particular is system default and Kerberos KDC tickets. So you have to be careful if you're trying to do this programmatically. Next thing I do is I copy and paste that long big string of numbers. I run scauth accept, put my user account name in, put the hash in, and it just goes, okay, did you ask me something? And then I do a list, and you can see that it's attached there. Now, the next section, which is all about attribute matching, this technically ties into pkinit, so we're going to be doing pkinit last. So when this actually works, and this is a capture from the screensaver logon prompt, is that when you wake the machine up, it will prompt you for username and password. When you put the smart card in, the username grays out, if the smart card is accepted, of course. And then the password prompt changes to a PIN prompt. You put in the PIN number of the card. If the card unlocks, you're allowed into the system. If you want to see what's actually on the card itself, this is the point where you use keychain access. And in this case, I got the keychain access little menu item in the top corner of the screen. And on the old method of doing things, your smart card appears as a secondary keychain to the system. And I've blanked some information out for obvious reasons. So that covers 10.11, all the way back to 10.6. But what's the future going to hold? Or rather, what does the present day hold and what's coming? Because let's face it, some of that stuff in the background there is not particularly nice. So on 10.12, as I mentioned earlier, Apple came up with a new API. It's called Crypto Token Kit. You can find plenty of WWDC videos on it. Currently, inbuilt driver support is only for PIV cards. But when you want to do things with it, Apple has made the configuration a lot simpler. You don't have to mess with the authorization database anymore, which in my mind is always woohoo. And you have a nice com.apple.security.smartcard profile. Most of these things are set as Boolean options. So you've got user pairing, which there's a pairing dialog when you plug one of these things in the first time. It will disable that dialog, but still allow existing pairings to work. You've got one called Allow Smart Card, which allows you to enable or disable that card for basic authentication. You've got Check Certificate Trust, and this is an odd one because the default on that is disabled. So that basically means on 10.12, with a PIV smart card using the new drivers, it does not do root CA certificate checking. So you could have a completely invalid certificate and still be able to get entry. Why that is off by default, I have no idea. Again, bug raised with Apple. If they're listening, please do something. This is horribly insecure. And then, of course, you've got one card per user because you've still got the potential that you could actually have more than one smart card with more than one certificate actually paired to a single user account. You may want that. I'm not entirely sure why. Yeah, exactly. Like you said, the military. But for a lot of different organizations, you're probably not going to want that on. You probably want to restrict that. 1 card per user. And once you've got that configured, as if by magic, on 10.12, using the new API, certificates from smart cards form part of the user keychain, which means they are accessible by anything launched by the user, like web browsers, which is really cool. They are not a separate keychain. The catch is they are not visible from keychain access. And if you do want to see any information of a CTK-compatible smart card, you're going to have to get dirty with the terminal and use the security command. And these are the commands. So this smart cards displays the information on anything that's plugged into the system and is being read by the system. Export, which kind of does the same thing. It says exports information, but it just dumps it on the terminal screen for you. And then, interestingly enough, you've also got smart cards, which does this one of the options that was in the profile that I mentioned earlier, which is a bit strange that they've implemented it in 2 different ways, but it's there. And then just for good measure, Apple has changed some of the terminology that they're using for these things. So hash matching with the old API is now called fixed key mapping, but it's exactly the same thing. It's just a bit of hash data appended to a user account. Again, on 10.12, you use the scauth command. Scauth, by the way, is actually a pretty complicated bash script that lives in USR bin local. It's well worth checking out because whoever wrote that's got some mad orc skills. You still have attribute matching with both methods, and we will cover that later. But if you have a new system and you have a blank smart card that's never been used before, and you plug it into the system, you get this nice little dialog box. And I took this when I first bought my Yubikey, because my Yubikey impersonates a PIV style smart card. And it asks you for card identity. Do you want that dialog to show again, cancel, or pay? Well, 9 times out of 10, you probably want to click pay, and that will then attach that card to your user account. The scauth command in the terminal has had some additions. All the previous stuff that we went through is now marked as legacy smart card support. Apple's pretty clear that the old way of doing things is not going to work much longer, and that they are deprecated. And this is the new stuff. So you've now got pair, unpair, pairing UI. So that's a 3rd place where you can turn that pairing dialog off. Identities. Any public key hashes are paired and unpaired identities on the inserted cards. So yeah, it just shows you what's plugged in. And of course, any hashes that are attached to the user with the list command. So down there at the bottom, I ran scauth identities. I got the PIV token there of the card itself and the unpaired identity attached to Yubikey down there. And then I used the pair with my username and put the bottom hash in. And it worked exactly the same as before, apart from, as soon as you hit enter, you get this. Smart card agent is trying to authenticate user. This is going to want the PIN number that's been set up on the smart card. So you enter it at this point. Next thing it asks is, for the logon keychain, it wants to know the password associated with the user account you're trying to attach this to. And this is so that in the future, it can unlock your keychain. So it's kind of handy to have. But once you've done that, you should all be okay. And then what basically happens is at the login prompt, you plug in your smart card, and the little prompt turns into a PIN prompt. You put in the PIN, and off you go. So a little extra goodies out of 10.13. Not much so far, not much I can actually talk about. But however, in System Profiler, they've added a new entry called SP Smart Cards data type. And when you read it out, it tells you what the reader driver it's using and what the smart card driver actually is. Early days on that one. Now, a bit of a warning. if you start doing OS upgrades, and I mean major version OS upgrades, not the point revisions, my card pairing got wiped on my user account. That's seriously bad, Apple. If I'm doing an OS upgrade in a managed environment, I want that stuff to remain there. I don't want to be upgrading people because of a security fix to the latest OS and then have to go through an entire setup procedure again. However, I've decided to do that setup procedure. I was keeping an eye on the Smart Card channel on MacAdmins Slack, which if you're interested, I would seriously recommend that you join. There's some very, very clever people in there. Some of them are a lot cleverer than I am. And some of them are trying to do things like run the old token D stuff and the new CTK stuff simultaneously. And the reason for that being, as you mentioned earlier, Robert, is because some of the applications out there can only read from the old system, and in particular Microsoft Outlook. So if you've got certificate-based authentication off to your Outlook server, and you're using Outlook to do it, it will not recognize new CTK stuff. Still waiting on that one. Yeah, and end of year. As Robert said, they didn't say what year, but end of year. The other thing is that when you actually have both systems operating, it's a bit hit and miss as to which one it hits when you try and log in. So if you've got two smart cards, but only one of them is used for login, you'll have an unreliable login process. So in short, pick one, stick with it until you can't stick with it any longer. Don't try and run both. If you do want to run the old legacy stuff, you can actually turn the new CTK stuff off. Again, it's also com.apple.security.smartcard. It's an array, and you actually have to specify which token that you wish to turn off. Now, currently, there's only one out there that I know of. It's supplied by Apple, and it's the PIV token. So in the array, you just give it that. Later on, when we've got more manufacturer support out there, then we'll have more PIV tokens to actually play with and do things with. But with any luck, you won't ever have to worry about this. Now, we come on to the next section, and before we do, I'm just going to have a little sip of this. Messing around with the pluggable accounts module for fun and profit. Yeah, nobody messes around with this for fun. If you're using a Yubikey, and I'm sorry this is Yubikey-centric, but you can hopefully translate this to something else, and you do pair your Yubikey with your system, you will actually find that your username and password still works. So you can still use it in place of. However, Yubikey have supplied a PAN driver that allows you to get past that. So there's a little package that you get and you install, and then you have to start making modifications to various files in / etc pam.d. I'm going to show you what, I'm not going to show you how, because this is dangerous stuff, and if you're familiar with Python or SED or any of those other file manipulation tools, go right ahead, but make sure you test this on a non-production system before you go right ahead. So the first one we're going to deal with is screensaver. And literally third line down, you insert a line, auth required, path to the module, and the extra stuff that it asks for, which is that mode equals challenge response. The part of this that's relevant for you all is that section there marked required. Because if you set that to required, you are locked. You need that token to unlock at that point. The password is not going to work. However, the other option, as you can see there on a different line, is sufficient. So if you don't have the card in, you can still use username and password. Up to you which one you choose and the requirements of your environment. Authorization. This one's actually the login window. Works in much the same manner. You stick the exact same line in. You say required if you want it locked to the token only. You make it sufficient if you want it to fail over to other means because you don't have that token plugged in. And the last one, and the interesting one, is sudo. This one's different. You put this one at the top and you make sure it's set to sufficient and you don't change that. If you don't have the token in, you won't get sudo. If you do have the token in, and you hit sudo -s in terminal, what actually happens on a Yubikey is the little light flashes. You get no prompts whatsoever on the screen, but the little light in your Yubikey flashes. That's your point if you've ever used a Yubikey to go forth and touch the little button, and then suddenly you have admin rights because it's doing the two-factor challenge at that point. If you put in required, it requires you to both press the button on the token and enter a password. That's why I don't recommend it. So now we get on to the next section, and I'm still debating over myself on the joke on this next slide. pkinit, or how I sort of learned to love Active Directory. And yeah, learning to relove Active Directory is like trying to forgive someone for infidelity. And yeah, my ex-fiance is not here, so that's okay. Too much? Yeah, okay. Apologies. So, pkinit is an interesting one. It first appeared in 10.6.3. It requires you to actually still bind your machines to AD. You're going to need an Active Directory with properly implemented Kerberos. You're going to need an internal certificate authority service. You're going to need that root CA installed on your system again so that all your certificates are nice and trusted. And it uses the same config as attribute matching, which I've hinted at earlier, not previously mentioned, because I didn't really want to go over it twice for you guys. And there's a few optional things that it's going to have. These things are actually true mobile accounts. They can be set to cache locally, but they do act as proper Active Directory for on-bound machine accounts, but this time using a card to log in. So the way it works is, in the beginning, when someone starts at an organization, a user account is created for them on the Active Directory. The AD is set up in such a way as to require smart card login with no username and passwords. There might be some sort of internally generated thing. It depends on how your AD is set up. That user is provisioned with an individual certificate. That certificate's put on the card and given to the user. When a user comes to log in, they put the card in the reader. The computer recognizes that card has been inserted. It will prompt them for the PIN. The PIN unlocks the card and releases the public key of the certificate on the card to the system. It takes that public key and then sends a Kerberos TGT request off to the Active Directory domain controllers. Okay? Your domain controller then checks that supplied cert against the record in its certificate authority. The certificate authority is going to reply back with whatever information. The TGT reply is then sent back from the domain controller to the Mac client. And it's either going to be a ticket or it's going to be a denial, because that card can be valid, it can be revoked, or it can be expired. And if it's the last two, it's not going to touch it. And once it's got that TGT, the system logs in as normal. User has a macOS environment as you've configured it, and they get on with things. And if they've got websites and things in the background that need that certificate to authenticate against, most browsers out there will do it. And you're happy as Larry at that point. And the reason I like this particular method is because there's no AD passwords, therefore you don't have the same keychain problems that you have whenever someone changes an AD password in the background and the Mac hasn't updated its keychain. So you avoid that horrible little error message. Kind of cool, huh? You can do it with the Apple plugin. Centrify and Admit Map PKI do make this easier. I haven't used Admit PKI myself, but I do have a reasonable amount of experience with Centrify. Centrify is obviously complicated to install on both server and client ends, but it will do the job. And it will do a lot of the PAM stuff for you as well. Because if you've ever seen what Centrify does to the install of a Mac, it installs a lot of things in a lot of places. You're also going to need all the stuff that we mentioned from Scene 24. Sorry, slides 49, 52, and 61. So when you download these slides later to go through, that's what you refer back to. The other thing that you should really do at this point is to say, because let's face it, you've gone to all this trouble of smart card login, security. You're going to encrypt the disk, right? So the thing you've got to do with File Vault 2 is disable the automatic login pass-through, because that's not going to work anymore. You are going to need something on the system that you can authenticate through File Vault 2 with, because the File Vault 2 screen is at the EFI screen and does not know how to address a smart card reader, probably doesn't even have network access. And so with a config profile, that's what you use. That nice little key there, you set it to the login window, and what that effectively means is user authenticates to File Vault 2, they then get a second login screen, they put in their card, they enter the PIN number, and away they go. Like I said, Centrify and Thursby do make a lot of this stuff nice and easy. I mean, ridiculously easy. Suffice to say, I think I had it running in 48 hours with Centrify. And most of that was dealing with back-end stuff. The Mac client configuration was ridiculously simple. Comes at a price. If you've ever seen Centrify pricing, you'll know why. If you've ever seen Thursby pricing, you'll know why. So for most people, they'll probably want to use the Apple plugin. So that way, we have to get a little more involved. So we've got some extra configuration goodness at this point. In the keychain access, you've got certificate settings, and this is to do with certificate pinning. By default, it's set to this. But if you do want to change any of this stuff, you're going to end up having to use some fairly complicated defaults rights commands, because these are user-level preferences. You might be able to get away with the profile if your system's set up enough, or you might have to get down and dirty and do this the hard way. You can set to use CRL or OCSP style, and I've got some notes in the slides here that tells you actually how to set the stuff, because the internal plist configuration as you change settings doesn't quite behave in the way that you would expect. So when you're doing things like turning it off, let's see now. So when you set things to OCSP, all the other settings have got to be set to 1. If you set to CRL, all the other settings are set to 1. If you set things to require both, the CRL sufficient and the OCSP have to be set to 0. So you just got to keep an eye on it. And if anyone's aware of my CIS work, which I fully put on GitHub, this is actually part of my repo. Now, does anyone spot the issue here? This is a user level preference. Yeah, absolutely. It's only going to apply after you log in. Well done. Have a chocolate. Sure, no worries. How does this work for the login window? The short version is it doesn't, unless you've got some sort of user level config profiles, and even then I can't guarantee that. So it's rumored that the next version of macOS might solve this problem, but currently for Sierra, that's the issue you've got. So how do you configure this with the old system on 10.6.3 all the way to 10.11? You need a nasty little file called cacloginconfig.plist that sits in etc. And literally that's the entire file. It's not even a properly formatted plist. You could tell that whatever was going on at Apple, there was a few people not talking to each other. This same file is used for attribute matching. This is why I wasn't talking about attribute matching earlier, because this is the exact same technology that you've got to fiddle with. And what you're doing is you're telling it to look for a field on the card, a field on the AD, and if you get a match between them, you're golden. And if you don't, go away. So with the CTK stuff, of course, they changed all of this. And you now have a file called /etc smartcard config plist, and the capitalization is very important. And during the course of 10.12's life, the spelling of this file has changed. So you've got to keep an eye out for these things. In Apple's own documentation, they just give you the key information. You actually need the full XML header on the top. So thanks to Dan Hoyt on the Smart Card channel on the MacAdmins Slack for pointing that one out. And like I say, this thing's also used for attribute matching as well. there's the potential of third-party authorization plugins. Is there anyone here who does anything at the NIH? Hi, Robert. You're probably aware of this. So they've got this third-party authorization plugin called the NIH Auth plugin, and I found really, really old versions of it out there, but I know you guys are actually using it internally with a far later version. Obviously, because the National Institute of Health is a US government organization, it's going to be using US government smart card standards like PIV. And I hear on the grapevine it will go open source as soon as it is approved to go open source. You're still going to need all the previous slides info, but this thing makes PK in it a little easier whenever it comes out. And now I have to apologize, no live demo because I could not spin up an AD on VMware and have VMware's natting play nicely. VMware, fix it. The other thing you've got is Joel Rennick's Nomad. Nomad does a really good job of doing Kerberos, and you get to keep your local accounts. And one of the things that I know is planning in a future version of Nomad is PKI support through smart cards. I know this because I've been trying to help him test it. I also know that I'm the only person it didn't work for. But Nomad's not the only solution. Enterprise Connect PKI is coming from Apple at some point soon. It is restricted to macOS Sierra and above, and CTK drivers and things upwards only. It will not deal with any of the legacy stuff. If you need to use the legacy stuff, use Nomad. This is not a sales pitch for Joel, although free licenses would be nice. So let's do some final thoughts. You're going to have OS release problems, because Apple are changing stuff all the time. As I'm sure you found when you try and remove your Yubikey from your system, it doesn't auto-lock your screen. It does mine. It's a weird one. Haven't quite figured that one out, but I found it most reliable when you use a config profile. If you have to use a third-party vendor and you're not reliant on Apple for certain things, so say you're using a third-party card supplier like Gemalto, you are reliant on them pushing drivers for new OS versions. This could delay your OS cycles, and if you're of a security mind, you want to keep your OS as up-to-date as possible. And I'm a big believer in keeping things as up-to-date as possible, if only for the fact that means you can immediately support new hardware when it comes out. As found in the smart card channel, the CTK attribute matching code in Sierra was present but not coded in until 10.12.4. I found that one out on the 27th of January earlier this year. Now at some point you guys are going to want to do some VM testing. Now my VM program of choice is VMware Fusion. I have not tried VirtualBox and I'm not a fan of Parallels. But VMware has some issues. So the packets that traverse from the card reader, from the card, to the OS are called APDU packets. And if you've got USB 3 turned on in VMware Fusion, it still, as of version 8.5.8, doesn't work. So you have to turn your VMware Fusion OS down to USB 2 and force USB 2 before it will work. Now 8.5.6 onwards got around that problem. So on version 8.5, the early versions of 8.5, if you plugged a USB reader in and had it attached to the host VM, it would actually show up as an OmniKey 3121 or an SCR 3500 or an SCR 3500A or whatever it was you plugged in. Now it shows up as a virtual CCID driver, CCID being the term for the driver used to talk through these things. So instead of passing through, it's now got its own virtual interface in a way. I have got no idea how well that works. It could be good, it could be bad. Now this is not a panacea to your security problems. You're just going to have some different ones. Does someone have a tampered smart card reader? So that's intercepting, so we've got a little bit of hardware in there that's intercepting the traffic as it's going backwards and forwards, and then somebody comes along later on, pulls an SD card sneakily out the bottom or something. Who knows? It's a possibility. Are you going to have weaknesses with the code running on the card itself? I know at least one organization that's busy replacing all of its cards worldwide, and then rewriting all of the little Java card applets that sit on the chip because they found that the encryption algorithms on the cards weren't strong enough. This is the whole SHA-1, SHA-2 thing. Does your PKI infrastructure, all your backend, however you've implemented it, whether it's Intrust or a Microsoft CA, does that have any implementation flaws? Is the security there? You know, you can be compromised in a whole bunch of different places. It's just usually easier to do it the client. The cards themselves are probably okay once you've got past all of that, but there's everything else. And when the 10.13 public beta started coming out, I did some VM testing, and I'll be perfectly honest, I think Apple missed a trick with APFS. The trick with APFS could have been that you had a tiny little pre-boot partition that did involve EFI to do file vault disk encryption. And you could have had smart card built in at that point so that you don't have to do any weird and wonderful user hacks. It's still not possible. It's still, as of the public beta, runs the same way. How do you defend against a hardware hack? These things are small and portable. How do you feel with someone just comes into your building, swaps them, and then comes back in a bit later on, swaps them back? Nobody notices, because who pays attention to that kind of stuff? Who pays attention to the keyboard and mice sitting on people's desks? Now, the big Mac general trend is away from directory services. And I'm going to give a shout out to Joel McTrill-Rennick here for popularizing it in the first place and now doing something to get us away from it. Like I said before, PKInit cert authentication means no more keychain password issues. And I don't know about you, but if you're working in that kind of environment, that is woohoo! 25% of tickets, says Robert here. I can well believe it. Yeah. I know the Mac places that I've worked as second line. Yeah, it was the second most common thing I dealt with. The first most common thing was time, but that's another story entirely. So with every version of macOS, including all the beta releases, Apple has been changing things like crazy. They are really going hell for leather on this. And to be perfectly honest, that's a good thing. We've actually got some support for the first time in years. And not just having to rely on third parties who are relying on bits of open sourced code that really haven't seen much love apart from a couple really committed people. If you've had a look at single sign-on solutions like Okta and Ping, I found online that they've now got the ability to do PIV support for single sign-on, which is really cool. So that certificate just has to be available. You sign in through a web page or whatever, and off it goes. As long as that cert is part of the keychain, it's available. So if you're browsing around a secure network because you have a large intranet that is secured through certificates, you can browse to the bits that you've been provisioned with, and then you can get told to cheerfully go away when you try to browse to the bits that you've not been provisioned for. It's kind of cool. That's the torch. It's up to you. So, buried in the OS is a whole bunch of man pages, and I will list them here. So you've got Smart Card Services there, which details a good chunk of this information. You've also got Smart Card Services Legacy for all the old stuff before it disappears. SSH Keychain, I did not touch this. I don't think it's ready for use yet, but you can have a look and see how your smart card hashes can be used to authenticate as over SSH connections. You've got PAM_SmartCard for doing all the pluggable account stuff, some of which I mentioned the Yubikey specific stuff earlier. scauth, that's the command I was talked about. Like I say, interesting little bash script. And of course the ubiquitous security command, which is being used for all sorts of things, but buried in the middle of the long list of things it can do was the 3 smart card options I detailed earlier. And big thanks and some links to these gentlemen. These guys have helped me out enormously, whether they meant to or not. One of them might even be here right now. and of course everybody in the smart card channel on the MacAdmins Slack. There's been little pieces of advice that I've found and read and got from all of these people at some point, and it has been absolutely invaluable. And I'm hoping that condensing it here in this presentation will help you guys if you're going down this. So I have to give a shout out to the MacAdmins podcast that I was in, which they amusingly titled Two Factors Enter. There's a chap who does a lot of open source stuff called Ludovic Rousseau. That's his blog page. He does a lot of stuff for Unix, but he spills over into the macOS world as well. He's done some of the earliest work on CTK that I've seen anywhere. He's a very, very intelligent guy. When I started off doing the smart card research, I found this thing from a guy called Random Oracle. I think he may have worked for Google, but don't quote me. And he wrote 4-part guide. I have my own smart card musings on my own site. So this leads us to the Q&A, and I was going to ask if there's any chocolate left, but I've only seen one person come up, so I'm definitely going to have some. And the only demo, actually, if you want to grab the link there, that's the feedback link. And if you want to see the final demo, this is what happens when you take a Yubikey out of the machine and it's all configured properly. Thank you very much. Just put that back in quickly. Yes. Mm-hmm. Right, so what we should do is really throw the catch box. I'll throw it to you first, because I'm terrible and I throw like a girl.
Who's asking?
I want one of these.
I just want to let you know that Centrify does have a free option for smart card for Macs.
Well, thank you very much. Yes, Centrify does have a free version. Any other questions, or are you just going for the good stuff? Yes, there is a manual and there is a lot of choices on there. Thank you.
Thanks for the MultiPurpose too.
You're welcome.
Thank you for the talk. Yeah, it's good to put a face to the name.
Yeah, no worries. No more questions? Well, in that case, folks, I guess you get to go early. Have a great day.